The Python PyTorch Basics. So what is PyTorch is? It's an open source machine learning framework widely used for building, training deep learning models. Okay, so the basics are it has tensors. Tensors are the core data structures in PyTorch, similar to NumPy arrays. So for example, in NumPys we have arrays. In PyTorch we have tensors, but it's more optimized for GPU acceleration. Okay, they support mathematical operations and are used to represent, for example, the inputs, the models, the model parameters, the outputs, and all those stuff. Right. Um, for example, let's say in React Native app, tensors can be used on the backend to process data before sending predictions to the front end. So it can process the data. Okay. So before sending the predictions to the front end. Next is first is tensors, and next is autograd. Autograd is nothing but the automatic differentiation. Okay, automatic differentiation is also called as autograd. So nothing but PyTorch's autograd module automatically computes gradients for back propagation. So it automatically computes gradients for the back propagation. It's essential for training neural networks. So there is something called as neural networks. So for training of that, we actually use autograd or automatic differentiation. Over here, basically what happens is in tensors with requires underscore grad, there is a parameter called as requires underscore grad. That has to be either true or false in order to autograd to work. It tracks operations and calling dot backward computes the gradients. Right. So for example, the relevance is it simplifies optimization of ML models that powers AI features in React Native apps. Next is neural network modules. So one, we have seen the tensors, two is autograd, and three is neural network modules. So something as the torch.nn module, it provides tools to build neural networks. The nn dot module is the base class for defining models. Okay, layers like nn dot linear, which is fully connected, or nn dot conv 2d, which is convolution, are combined to create architectures. Right. The relevance is models built with nn dot module can be exported to formats like ONNX or TensorFlow Lite, something like that. The models are built with this. The next one is training loop. The training which involves defining a model, something like a loss function, nn.msc loss, and optimizer, torch.optim.sgd, like that. Over here, we actually use forward pass, compute loss, back propagate gradients, and all those stuff. Right. And the last one would be GPU support. The PyTorch supports CUDA, CUDA for GPU acceleration, enabling fast training and interface. Right. So the last one is dynamic computational graphs. Basically, PyTorch uses dynamic, which is eager computational graphs, unlike static graphs in some frameworks. This allows flexibility. You can use Python control flow, for example, the if statements like that. So what all we said? Tensors, autograd, neural network modules, training loops, and GPU support. And the last